All right, for section 12.5, we're going to look at problem solving with the normal distribution, and we first need to remind ourselves of a few things, okay? So first, what is the normal distribution? Well, remember, the normal distribution is a special theoretical type of frequency distribution that models real-world situations. It's that perfectly symmetric bell curve. All right. So this is kind of like a histogram. We looked at an example in the previous section where we had, I think it was adult male heights in North America or in the US, and we had four different histograms. And we had a histogram with a particular sample size, and then we increased the sample size, and then we increased it again. And as we kept increasing the sample size, we were approaching this theoretical, perfectly symmetric normal distribution. Remember? The center of this is the mean, technically the mean, the median, and the mode. And then we'll use iterations outside of the mean called standard deviations. Okay, so the standard deviation is kind of how spread out the data is compared to the mean. So when we talk about a normal distribution, we will always describe it by the mean and the standard deviation. Okay, the normal distribution is used to estimate probabilities, compare different data sets, and make predictions about populations. We did this comparing data sets in the previous worksheet. We looked at the SAT and the ACT, both standardized tests that measure the same ability, but they're scored very differently. So if you take both the ACT and the SAT, you don't necessarily right off the bat know which one you do better on. But understanding this idea of z-scores, we can calculate the z-score for both sets as long as we know the mean and the standard deviation, and we can see which one we actually scored better on. So in this case, higher above the mean, the better; lower below the mean, the worse you did. Okay? Now, we also have z-scores. Z-scores basically give us a position in a standard deviation. So when you calculated a z-score, it's going to describe how many standard deviations above or below the mean a particular data item is. Okay, so where in this normal distribution is this data point? Is it above or below the mean, and how many standard deviations away? What's nice about z-scores is you don't have to be exactly 1, 2, or 3 standard deviations away. When we were looking at the empirical rule, that 68, 95, 99.7 rule, we were looking at data items that were exactly 1, 2, and 3 standard deviations above or below the mean. Here, we can have any number of standard deviations above or below the mean. Okay, so wow, z-scores describe how many standard deviations a data item is from the mean of a normal distribution. It is a way of standardizing data values so that we can compare across different distributions. Again, we did that with the ACT, SAT situation, okay? And we've got the formula here for a z-score. Remember, you take your data item, you subtract the mean, and then you divide by the standard deviation, okay? Now, a percentile is another way to indicate a location in a standard deviation, okay? So a percentile indicates the relative position of a specific data value within a normal distribution, okay? So when you're looking at percentiles, we're going to basically have a percentile. It's going to indicate what percentage of data falls below a particular data point. So if I say your kid scored in the 95th percentile on some EOC, that would indicate that 95% of kids that took that same EOC scored less than your kid. Okay, so you have to remember that when we're dealing with percentiles, it is the percentage of data that fall below a particular data point. Okay, and basically, because percentiles and z-scores both are a way of finding a position in a normal distribution, we can use them together. So what we will end up doing is we will take z-scores and convert them to percentiles using a table of values that I'll make sure is posted in Moodle. But we're going to use this percentile table. So we find a z-score, we use the z-score in the table to convert the z-score to a percentile, and that allows us to answer questions about what percentage of data fall below, above, or between data points. Okay, so that's what this is saying right here. So this says, since z-scores and percentiles both represent a position in a normal distribution, we can use z-scores to find a percentage of data below, above, or between specific data items. And again, our mission is going to be convert z-scores to percentiles using, I'm just going to put the table, okay? So using the table, alrighty. So we're going to look at finding the percent of data below a data item, finding the percent of data above a data item, and then finding the percent of data in between two specific data items. So for topic one, we're going to very specifically look at finding the percent of data below a particular data value, okay? So we compute the z-score. We use the table, and I'll show you the table in just a moment. We use the table to find the correct percentile, and then note the table gives the percent below or to the left of a normal distribution. So if I have a data item that is right here, okay, the percentile is going to represent this. So the percentile represents percent of data to the left of a specific value in the distribution. All right, so keep that in mind. Once you get your z-score and you convert it to a percentile, that percentile represents the percent of data below a specific point, okay? So for example, excuse me, for example one, it says find each probability or find each percentage, okay, is what we're gonna think of it as. Hold tight, let me scroll just a little bit. Okay, so it says for part A, the height of men are normally distributed with a mean of 70 inches and a standard deviation of 3 inches. I should have put in here the heights of men in North America, so just do know this means in North America. So the height of men in North America are normally distributed with a mean of 70 inches and a standard deviation of 3 inches. Find the probability that a man is shorter than 73 inches. Okay, so the first thing we have to do is find a z-score for 73 inches. So we take the actual data item, 73, we subtract the mean, and we divide by the standard deviation. So 73 minus 70 is 3. 3 divided by 3 is 1. So we have a z-score of positive 1. What we now do is go to the percentile table. It is in your book. It's probably in your MyLab homework, but I will also post it in Moodle, okay? So let's switch over to the percentile table. So this is the percentile table. What you want to do is notice that each column has a z-score and a corresponding percentile, a z-score, a corresponding percentile, and so on. So we want to scroll until we find a z-score of positive 1, okay? So that would be right here, alrighty? So let me actually draw your attention to it. There's our z-score of 1, okay? Its corresponding percentile is 84.13. This percentile represents the percent of data that fall below our data item, okay? So we've got 84.13. Let's go back to our worksheet. All right, so the percentile is 84.13%. And this represents the data items or the percentage of data items that represent men shorter than 73 inches. So 83 or 84.13% of men are shorter than 73 inches. And I do want to put approximately here. This is a lot of us making predictions, so we're not getting necessarily exact values, but we're saying, hey, based on this normal distribution, we can say approximately 84.13% of men are going to be less than 73 inches tall, okay? And you just have to kind of read into the problem. We wanted shorter than 73, so that would be heights less than 73 inches. And remember, from the table, the percentile gives you the percent of data below a particular data item or below a particular point, okay? Let's look at another example. Part B says the distribution of monthly charges for cell phone plans in the US is normally distributed with a mean of 62 inches and a standard deviation of, or 62 inches, God almighty. It says here the distribution of monthly charges for cell phone plans in the US is normally distributed with a mean of $62 and a standard deviation of $18. Find the percentage of plans that have charges less than $83.60. So if we were to draw this. We have our mean of 62. We have a data item here of $83.60. We want to know what percentage of plans are less than $83.60. So we're looking for the percent of data that fall below this point. Okay, so let's find our z-score first. We take our data item, which is 83.60. We subtract our mean, which is 62. We divide by the standard deviation, which is 18. If you have not yet, get your handheld calculator out. So I've got 83.60 minus 62, so that's 21.60 divided by 18. And we get a standard, or a z-score, not a standard deviation. We get a z-score of 1.2. What this means is $83.60 is 1.2 standard deviations above the mean. But what we're really interested in what percentage of plans are going to have values less than $83.60. So we need to take this z-score and convert it to a percentile, okay? So percentile. Now, we need to go back to that table, and we're looking for positive 1.2 for the z-score. All right, so positive 1.2 for the z-score, that is right here. And a z-score of positive 1.2 has a corresponding percentile of 88.49. So 88.49% of data plans, or cell phone plans rather, are less than $83.60. All right, so remember, when you get this percentile from the table, it automatically represents the percentage of data below a particular data item. So when we're looking for percentage of data of rather cell phone plans less than $83.60, it's really easy. It's that direct percentage from the table. Now, what if for fun, okay, for fun, or I think I've called it funsies before, for funsies, what percent of plans are greater than $83.60? Well, the full distribution, if we go back and look at this little picture that I drew, okay, this entire distribution right here represents 100% of data plans, assuming we got information on every single data plan, let's say in the US, okay? This little graph that I drew would represent 100% of those plans. 88.49% of plans are going to be charged less than $83.60. So what would this be? Well, we would take 100%, subtract 88.49, and that would tell us the percentage that's left over to represent data plan or cell phone plans that are going to have charges of more than $83.60. So we take 100, we subtract 88.49, and we get 11.51% of cell phone plans are more than 83.60. Now, I don't know the accuracy of this actual data. This is an old problem from an old iteration of a book from several years ago. Data plans today might be way different than this, but assuming this information of mean and standard deviation is true, this would be the situation. So 88.49% of cell phone plans are going to be less than $83.60, which means by default, 11.51% of cell phone plans are more than $83.60. Okay, so that is how to calculate the percent of data that fall below a particular data item. In the next video, we'll look at finding the percent of data above a particular data item.